Welcome back to our channel. So there was a question which was asked in JEE Main 2018. Code was C and question number 71. This question was based on momentum. If you say last video was on impulse, so we tried to get a continuation video, and fortunately there was a question asked in JEE Main 2018 as well. So this was the question. It is found that if in a reaction a neutron suffers an elastic collision, so since there's elastic collision, the limiting coefficient will be equal to 1. With deuteron at rest, so for deuteron, the mass is always twice of neutron. So therefore, we are considering if m is the mass of neutron, then the mass of deuteron will be 2m. The fractional loss of energy is Pd, while for similar collision with carbon nucleus at rest, so in the next case, we'll be considering a carbon nucleus, and that too at rest, the fractional loss of energy is Pc. The values of Pd and Pc are respectively. The options are 0.28, 0.89, 00, 01, 0.89, 0.28. So just take a pause and imagine that if you were to give this exam in 2018, how you would have solved, or what would have been your workflow to go ahead with this question. Take a pause, decide. So I hope you have decided a bit. So now let's begin. So see, what was the first case? That there is a reaction. A neutron of mass m collides with a deuteron of mass 2m, and this is before collision, and let the initial velocity be v0, and this was at rest, so therefore the velocity is 0. And after collision, the v0 changes to v1 and the velocity of deuteron changes to v2. So this is after collision, this is before collision. So what will be your workflow? I told you to develop your workflow, so I'll be discussing here what will be my workflow. So see, since this is given, so we will be using law of conservation of momentum, and from this we'll try to find the relation between v0, v1 and v2. Once this is done, we can get the relation between their respective kinetic energies. So kinetic energy 0, kinetic energy 1, kinetic energy 2. And once you have found the kinetic energy, you can also find the fractional loss. So first we'll do this for deuteron, and next time we'll repeat the same thing with carbon nucleus. So I hope you are clear with the workflow. Okay, so let's use the law of conservation of momentum. So the initial momentum of the system should be equal to the final momentum of the system. So initial momentum m v0, mass into velocity, plus 2m into 0, that will be 0, is equal to m v1 plus 2m into v2. So m cancels, so this is the equation. What we are getting is v0 equal to v1 plus 2v2, equation 1. Now we have already told that this collision is perfectly elastic, therefore E is equal to 1. And if E is equal to 1, the velocity of separation, or else I will first give you a hint about this E as well. So E is nothing but velocity of separation upon velocity of approach. So velocity of separation is given by v2 minus v1 upon velocity of approach is given by v0 minus this velocity, which happens to be 0 in this case. But since the value E is equal to 1, both the values will be equal. So the second equation is v2 minus v1, velocity of separation, is equal to velocity of approach, that is v0 minus 0, that is v0. Equation 2. Solve both these equations simultaneously. So we will get values as, first add this, so v1 minus v1 will get cancelled, so we'll get the value of v2 as 2v0 by 3 and v1 as minus v0 by 3. So we have found velocity. Now what we'll be finding? Now we'll find the kinetic energy, or else the partial loss of kinetic energy. So the partial loss of kinetic energy in this case was P D, that was given in the question. So now PD, fractional loss, is given by, what will be the equation for this? That will be half m. So first kinetic energy, half m v square. So what was the initial velocity? Half m v naught square minus, now half m v naught has changed to v1, and what is the value of v1 that we got now? Minus v0 by 3. So minus v0 by 3 the whole square upon the normal initial one, that is half m v0 square. So half m cancel, this will be v0 square minus this minus v0 square by 3 upon half m v0 square. So finally we will be getting PD as 8 by 9. So this was for the first condition, that when it was colliding with deuteron. Now for the next half, we will consider the same thing. Now we'll be doing it with carbon. So now what will be the only change? Try to imagine the change. So the change here, the mass of carbon nucleus, it will be now 12m, because we know the mass of carbon is 12. Rest all we are keeping as the same. So again, now what will be the before collision? mv0 plus here, now it's 12m. I think it's not visible due to the light, so I will write it somewhere different. So the mass is 12m. Okay, so now let's continue again. So mv0 plus 12m into 0, which will be 0. Then mv1, again this mass will change to 12m, because now we are using a carbon nucleus. So plus 12m v2, mm cancelled. The equation what we are left with is v0 equal to v1 plus 12 v2. Let this be equation number 3. Again, since the collision is elastic, so therefore the velocity of separation here, it is v2 minus v1 is equal to velocity of approach v0 minus 0. We have already explained this. Equation number 4. Solve both this simultaneously. So therefore we will get v2 as 2v0 by 13 and v1 as minus 11 v0 by 13. And so PC, that is a fractional loss of kinetic energy, that will be given by half m. What was the initial speed? v0. So half m v0 square minus what's the final speed is half m v1 square. Now what is v1? Minus 11 v0 by 3. So minus 11 v0 by 13 the whole square upon the initial speed, that is half m v0 square. So if we solve this will be 13 square 169. Will half m will cancel. So finally we will get 48 by 169. So we have got the PC and PD. This is our PC and this is PD. Now since this calculation is very tough, so let's use now examples, the options which were given. So if you see the option, first of all, this 0, 0 and 0, 1 should get cancelled, because 0, 0 and 0, 1, this can't be that. Now the remaining options are 1 and 4, that is 0.28, 0.89, 0.89, 0.28. So now tell me which one is the bigger. Among this, which one will be bigger? Obviously this 8 by 9, because it is covering most of the parts of 9. So that means PD will be greater. So your first one was PD, and PD value should be greater than PC. So among this, the only value which is greater is this one. So 0.89 is greater than 0.28. And you can also calculate, if you have some techniques, you can also calculate. We can also make a different video for this. So therefore, the correct option is option 4, 0.89 and 0.28. So once again, what we did, the overall, that we first calculated before collision law of conservation using law of conservation of momentum, that is m initial velocity of the system should be equal to final velocity of the system, and we got an equation. Then since this collision was perfectly elastic, so therefore we know that the velocity of separation should be equal to velocity of approach. We got this equation simultaneously solved. We got the values of V2 and V1. Then for fractional loss PD, that is initial kinetic energy of this neutron minus final kinetic energy of the neutron upon initial kinetic energy of the neutron. In the same we found PC, and now finally the answer. Thank you.